Now that we've looked at a lot of the facets of creating an assembly, let's take a quick look at motion studies. Let's open up Swingarm Assembly 6 and go into Motion Study 1. If you don't see Motion Study 1, go to your Assembly tab and select New Motion Study. As a note, if you're using SOLIDWORKS Premium, you can go to Tools and Add-ins and turn on SOLIDWORKS Motion. That'll give you a little bit more in terms of options when you go into your motion study. Inside of a motion study, by default, it'll be set to animation. You should see animation and basic motion. If you have motion study turned on, you should also see motion analysis. We're going to go into motion analysis and we're going to apply a few things here. Now, the first thing I want to note is simulating sketch blocks is great. It's a great way to look at the dynamics and the kinematics of motion. But if you'll notice when we move our sketch blocks inside of the assembly environment, the linkage, the solid parts don't update until we rebuild the file. And this does produce a problem inside of the motion study. So what we want to do in here is we want to limit some of the mates that we have between our sketch block, our layout sketch, and the components. So we're not going to be able to accurately simulate the motion between a sketch block and a solid component inside here, and you really only want to do either sketch blocks or solid components. So in the mates folder, we're going to look for the coincident constraint concentric 4 and suppress it. So that way, it's no longer driving the rest of the assembly. We can move these components up and down, and they're no longer fixed. So the next thing we want to do is we want to try to move our components around. If we go back to our model and expand the mates, you notice that concentric 4 is not suppressed in here. So anything you do in the motion study doesn't translate back out into the assembly. But let's come out here and let's suppress it here as well, and let's move components around and see how it works. So you'll notice that for whatever reason, this assembly is locked. You see that things are still moving around. Well, let's take a look at what other sketches are holding our components together. Concentric 7, let's go ahead and suppress that as well. Now we can move these components around and not worry too much about it. So really what we want to do is we want to look at the motion between a few of these components. So let's go back into our motion study and look at our different mates here. We want to come down and we want to find concentric 7, and we'll suppress that as well. So inside here, there are a few things that we can do. We can apply motors, which can be linear or rotational, springs and dampers, forces, which can be linear or rotational or torque, and we have contact sets. When you're using motion analysis, you can also apply gravity. The great thing about motion analysis is you have the available option to export to simulation. If you have simulation turned on, you can export simulation setups at various steps throughout your model. First thing we're going to do is apply a spring. We're going to use a linear spring, and we're going to go from the upper spring perch to the lower spring perch. You get a preview on the screen as if we go down into the properties, you can see that we can define the spring constants, the spring length, we can update when models change, we can apply a damper in here if we wish, and we can adjust the display. For instance, if we want this to be 125 millimeter diameter, 10 coils, the diameter of the coil as well. There's also an option for load-bearing faces. Now, if we simulate the model, we have a spring in here. Now, of course, this is just a graphical representation, but it does apply all the properties we selected. The next thing we can do is apply a force. Now, in this case, it's a little bit of a cheater, but we're going to go ahead and apply a force to the bottom of the shock, and we're going to show what this does. We'll rotate this around, and we'll apply a pretty large force of 50 newtons. So now, if we calculate the results, you can see it's actually compressing the shock. And because we don't have our linkage fully constrained, as we go back and play it, what's actually happening is it's pressing this up. I'm going to slow down the playback and we'll play it from the beginning. So you can see this allows us to actually simulate what's happening between the spring and the force applied to it. Now, if we had a solid component here for the swing arm as opposed to having just a sketch block, then we would have a fully constrained model. But unfortunately, we don't have that option, so we have this sort of random motion going on. But if we stop this and we come back, we can go back in and we can modify, in this case, the linear spring. We can apply a damper. And if we have a heavy enough damper, it will actually limit the amount that the spring can travel. So let's recalculate this. And you see that it limits the motion and allows us to really reduce the amount of motion that's going on here. But in general, motion studies or motion analyses are a great way for you to take a look at your mechanisms, your assemblies, and your motion, and figure out how they interact in the real world. The contact set is great to do things like simulate gears, simulate solid components like cams and lifters, and really get a good idea of how things are going to interact between each other. When you're done with this, you can also do things like save out the animation. These are, again, great options to really take it to the next level and export your animations either from the SOLIDWORKS screen or even render them with Photo V360.